Welcome. Yes, our cruise today, our math cruise, takes us to ancient Egypt. And it is in ancient Egypt that we're going to learn a little bit. Here are some pyramids. And we are going to jump on the camels and we're going to make our way out to the Great Pyramid of Giza. We'll have many moments that are very much Raiders of the Lost Ark moments. Here, I'll go on ahead of you and I'll stop at the tomb of Tutankhamun, which is King Tut. Here's part of our tour group, and there's old Mr. West right there going on ahead, waiting for you guys to come on and join us other students on the cruise boat that'll take us up the Nile River. Let's have a little fun. The tourist police are pointing out fun photos for us to take for our friends. Let's take a little break and rest. How about we check out some treasures from thousands of years ago that we can actually reach out and touch. A mosque, perhaps. We can stop and check it out. The Great Colossus. Open air museums. Oh, what does that say? No climbing on the Great Pyramid, but I'll go ahead and pay a small bribe to the tourist police, and they'll probably let us scamper up about 8 or 10 rows. It's about that height you start getting scared when you look down anyway. No harm done. I assure you, with my fez, I mean no insensitivity to Egypt or the Egyptian culture. I actually got this fez from Egypt, from the tourist police. He traded me my hat for the fez. They don't really wear fez that much anymore in Egypt as they used to, but it's still a good thing for us tourists as we go check it out. So with fez on head and other things to come, let's dive into the math. I'm glad you caught up with us. All right, travelers, I'm going to show you problem 31, angle of depression. I'm not going to give you the answer. I'm just going to help you set it up. Let's look at it this way. If the angle of depression, remember that means we've got one horizontal side and one side going down. Right? The angle of depression, or maybe it could be this way. We don't know. One horizontal side and one side going down. If the angle of depression from a helicopter to a landing pad is 37 degrees, well, let's draw that. Let's draw our helicopter. Terrible helicopter. But let's say that we have the landing pad right. There's our landing pad. And it says the angle of depression from the helicopter to the landing pad is 37 degrees. Let's draw some other stuff. Let's draw the ground. We should always draw the ground. So there's the ground. And let's draw, you know what? Let's draw a horizontal line because we're going to need that. We're going to need that because we're talking about an angle of depression, and an angle of depression always looks down. Always looks down. So let's draw that angle of depression from the helicopter to the landing pad. So this is going to be our angle of depression in here. So this angle in here is going to be, that's our angle of depression. That's going to be 37 degrees. 37 degrees. Remember, an angle of depression always has one horizontal side and one looking down side. There's our landing pad at the time. So we are 1,250 feet from the ground. in this helicopter, flying over the pyramids and the Sphinx and all of that. 1,250 feet off the ground over beautiful Egypt. What is the horizontal distance from the helicopter to the landing pad? Interesting. So there's our position once it gets directly above the landing pad, and here's our length from the helicopter to the landing pad. This is where we need our X. This is what we want to find. The distance from the helicopter to a position directly above the landing pad. This is our horizontal distance from helicopter to the landing pad. Okay, so we have some values here, and we have to do some thinking. We have our angle of depression. We need our X here. We need another value. I'm looking at just this, right? I'm looking at just this triangle here. So I need either this side length or this side length. I need one or the other. Do you see how I can maybe find one or the other? I think I see a solution here. How about this 1,250 feet? If this is a rectangle and opposite sides of rectangles are congruent, this has to also be 1,250 feet from here to here. Now we have our right triangle, because of course this is a right angle. We have our right triangle. We know what length we need to solve for. We need X, the distance from the helicopter to a point directly above the landing pad. We have our angle of depression, and we have a side. So our angle of depression is here. Let's label our sides. This is going to be the side that's furthest away from the reference angle. So this is going to have to be our opposite side. This is going to be our hypotenuse because it is the furthest away from the right angle. Then this must be, that's the side that touches our angle, the leg that touches our angle. This has to be the adjacent. Let me remind ourselves of. So which trig function are we going to use? Well, let's look at our triangle. We have an X for adjacent, so we know we need adjacent. We have a value for opposite, so we know we need opposite. There's nothing here for hypotenuse. So anything that uses hypotenuse, we cannot use. So that eliminates sine and cosine. That means we're going to use tangent, which is opposite over adjacent. Now it's just a matter of filling in with our standard equation the tangent of 37 degrees. Our opposite is 1250. Our adjacent is x. So I'm going to have to do a little bit of algebra here. If I want to get rid of the fraction, I'm going to multiply both sides by x. If I take 1250 and multiply by x, then divide by x, I'm just going to be left with 1250. And over here I have x times the tangent of 37 degrees. I only want x. I want x by itself. So I'm going to actually divide both sides by the tangent of 37 degrees. I'm going to convert the tangent of 37 degrees to a decimal so that it's easy to deal with. So I take my calculator. I'm going to set this up as 1250 divided by And in my calculator, I'm going to press clear. And then I'm going to type in 37 and press the tangent button. And that gives me 0.7536. 0.7536. Now it's just a matter of putting that in my calculator. Clear. 1250 divided by 0.7536, and I come out with 1,658.7 feet. That is my distance right here. My distance from my helicopter horizontally to a position directly above my landing pad. Now, these side-solving equations can be outrageously confusing. So go ahead and rewind your video and watch it again if you need to, because you're going to have to draw these out as they're given to you down here. Be very, very careful to remember angle of elevation. Be very careful to remember, okay? Angle of elevation. One horizontal side and goes up. Angle of depression. One horizontal side and goes down. Do not, please do not forget that. Elevation, depression. Good luck. Let me know if you have any questions. One last comment I happened to see when I was reviewing the video before posting it was I didn't show you algebraically right here. When you have x times the tangent of 37 divided by the tangent of 37, that cancels out. So now you just have x by itself. Right there, 1,658.7 feet.